So the first one is geometry, uh, and it reads as follows: let ABC be a triangle, and let D be an arbitrary point on the perpendicular bisector of BC. So essentially, this line here. Suppose that the internal angle bisectors of angle ADB and angle ADC intersect AB and AC at x and y, respectively. Show that XY is parallel to BC. So to start, I'll just mark the angles here. So these two angles are congruent. And also, these two angles, okay, hold on. These two angles are also congruent due to the angle bisectors. So our goal here is to show that XY is parallel to BC. I'll let you guys think about this first for a few minutes. Okay, so I'll start going over this problem now. Notice that we have some angle bisectors here. So one thing that we can do is to try the angle bisector theorem. Now, what is the angle bisector theorem? Suppose we have a triangle here and an angle bisector here. Then I'll name these as A, B, C, and D. Then A over C is always equal to B over D. This is called the angle bisector theorem. And you can cite this in your proof without explaining basically the proof of the theorem. There. So we can use this on two triangles. Okay. Um, what triangles do you guys think we should use this theorem on? ADX and BDX. Actually, let's just refer to the whole triangle. So ADB, this one. Hold on. ADB here. And what's the other triangle? Notice that we have two angle bisectors here. Yes, ADC as well. This one, right? So notice that if we do the angle bisector theorem on triangle ADB, then we have that DA over AX is equal to uh, DB over BX. And from triangle DAC, we also have that hold on, dA over AY is equal to dC over CY. Okay. And another thing, note that we're asked to show that XY is parallel to BC. And I'll just erase this. Um, and this configuration here with XY and BC should look a bit familiar to some people here. So what do you think can we prove to ultimately show that XY is parallel to BC concerning triangles AXY and ABC? Yeah. So essentially, another way to state this is uh, we we want to show uh, that triangle AXY is similar to triangle ABC. Okay, and that could ultimately give us these two equal angles, and we can get the parallel from there, right? And a good thing to aim for is to show that AX over AB, actually, AB over AX equals AC over AY, right? So essentially, we already have two ratios here that already have all of those lengths. And And what we would want to do is we would just want to manipulate these ratios. So I'll just name this 1 and 2. Okay. And so if we want to manipulate ratio 1, we want to somehow get an expression for AB over AX. What I'll do first is I'll rewrite it as follows. So 1 implies this Bx over Ax equals dB over dA. Okay. And to get AB over AX, that is just 1 plus this ratio, right? Because AB equals AX plus AX plus BX, right? So hold on. Yeah. And so we get that AB over AX equals 1 plus B. Actually, I'll just write the entire thing out. This is just AX plus BX over AX, or 1 plus BX over AX equals 1 plus the dB over dA. And then for 2, we can do the same thing also. This time we want AC over AY. I'll not write everything out anymore. If you're doing the same thing for two things, you can also say like similarly, this is also true for two or something like that. Uh, yeah. So AC over AY equals A AY plus CY over AY equals 1 plus CY over AY. And that's the same as 1 plus oh no. Yeah, 1 plus DC over DA. Wait, hold on. Yeah, and self-similarly, you can also do analogously. That would also work. If now we want to find a way to link these two, right? These two expressions, so that we can ultimately say that AB over AX and AC over AY are equal. Uh, our, the way to do this is to notice, you can also check from the diagram that dB indeed equals dC, right? A well-known fact is that since this is the perpendicular bisector of BC, okay, we immediately know that dB equals dC. So since dB equals dC, we have, I won't write everything out anymore. Vx over Ax equals AC over AY. Okay. So essentially we have the proportion that we want already. Then we just want to show the similarity. So we're going after SAS here. So we also want to show the angle, since angle BAC equals angle XAY. We have triangle BAC. I'll just write ABC. Triangle ABC is similar to triangle AXY, pardon the handwriting, um, by SAS similarity. And therefore, this is the therefore symbol over here. Um, Therefore, we have angle AXY equals angle ABC. And so XY is parallel to BC, which is what we wanted to show. Any questions? I'll show an example of fully written proof for this question. You guys might want to take a screenshot, but it will also be uploaded in the sample problems document maybe later or tomorrow. So here, notice that here we wrote everything up, kind of. So like, for example, here, since AB equals AX plus BX and AC equals AY plus CY, then we have this. But note that instead, I wrote this entire thing as just one equality. So it's just a chain here, right? Then we have this, and then therefore, yeah. So generally, a well-written proof will look something like this.